Hello children, welcome to another session of PYQ Advanced Discussions. So now I am with an organic question, a previous year 2023 JEE Advanced paper, a question from nitrogen containing compounds. The question is put there, you can just have a look at the question. It was a numerical question. A trinitro compound 135 tris 4 nitrophenyl benzene. So you can also take it as a nomenclature question. You have to write the structure correctly. On complete reaction with an excess of tin in HCl gives a major product, which on treatment with an excess of NaNO2 in HCl at 0 degrees Celsius provides P as the major product. Upon treatment with excess of water at room temperature gives product Q. Bromination of Q in aqueous medium furnishes the product R. The compound R upon treatment with an excess of phenol under basic conditions gives the product S. The molar mass difference between compound Q and R is 474 gram per mole and between P and S is 172.5 gram per mole. The number of heteroatoms present in one molecule of R is X. The total number of carbon atoms and heteroatoms present in one molecule of S is Y. Then X plus Y equal a numerical question. So let us go to the question directly now. A trinitro compound and the compound's name is given 135 tris 4 nitrophenyl benzene. So it is a substituted benzene. The starting material is a substituted benzene. So let us take benzene. At its first, third and fifth position, you have 4 nitrophenyl groups. So suppose if I take this as a first carbon, then here there is a nitro group, and at the third carbon 135, third carbon you have a nitro group, and at the fifth carbon you have a nitro group. So this is the starting compound, and this on complete reaction with an excess of tin in HCl. So we know nitrobenzene is reduced by tin in HCl to amino functional group, primary amino functional group. NO2 is reduced to NH2. So with excess of tin in HCl says all the nitro groups will get reduced. All the nitrobenzenes will get reduced to amino functional group. Aniline will be formed here. All the three positions you will have aniline now, NH2, and which on treatment with an excess of NaNO2 HCl at 0 degrees Celsius. So this reaction is diazotization reaction of aromatic primary amines. Aniline undergoes diazotization where at all the NH2 diazotization takes place, resulting in benzene diazonium chloride will be formed here. All the primary aromatic amino groups will undergo diazotization, forming, everywhere you will have diazonium chloride now, N2Cl. And this compound is called P. This is the compound P. The compound P on treatment with an excess of phenol under P upon treatment, P is formed here, and P upon treatment with excess of water at room temperature gives the product Q. So we know benzene diazonium chloride at room temperature with water undergoes nucleophilic substitution of diazonium group by water. From there H plus is eliminated and you will get an OH group there. Phenol will be the product form. Benzene diazonium chloride when treated with water at room temperature gives phenol as the product. So all the three groups will become phenolic groups now. And now you have benzene ring with OH here. At the third position also a phenolic group will be there. And at the fifth position also there will be a phenolic group. And this compound is called Q. With excess of water, Q is formed. And then it says this compound Q is subjected to bromination in aqueous medium. We know phenol when subjected to bromination in highly polar solvents, at a stretch all the three, 2 ortho and 1 para can be brominated. Here all the para positions are already occupied. So each phenol groups, both the ortho positions will be brominated. So when you treat it with an excess of water, a bromine in water, you are treating it with bromine in a highly polar solvent, water aqueous, bromine in water. All the three positions can be brominated, electrophilic aromatic substitution. But since all the phenolic groups, para positions are already occupied, each one's ortho positions, both the ortho positions will be brominated, because we know OH on benzene ring is a highly activating and ortho para directing group. Same thing you can put in the fifth position also. OH here, both the ortho positions of this phenolic group will be brominated. And this compound is called R. In aqueous, Br2 in aqueous medium gives R. This compound is called R. So we have written P, we have written Q, now we have got the compound R. Now an important information is given here, that is the molar mass difference between Q and R is. This is Q and this is R. The molar mass difference is 474 gram per mole. So let us see in Q and R what is the difference. The difference is from Q, 6 hydrogens are substituted by 6 Br. That's a difference. Instead of 6 hydrogen, each phenolic group, 2 hydrogens, 2 H plus at the ortho positions are substituted by 2 Br plus each. So the difference should be 6 molar mass of bromide minus 6 molar mass of Br plus is substituting H plus, minus 6 molar mass or 6 atomic mass of Br minus 6 atomic mass of hydrogen. We know atomic mass of bromine is 80. So the difference which should be 6 into 80, 480 minus atomic mass of hydrogen 1. So it should be 6 into 1, 6. The difference should be 474 gram per mole, and that is what is said here. So Q and R must be these compounds. Now let us come to the question. The number of heteroatoms present in one molecule of R is. So heteroatoms in an organic compound, any atom other than carbon and hydrogen are regarded as heteroatoms. So we know in R, all the bromine and all the oxygen are the heteroatoms. So we know there are 6 bromine. Each ring has 2 Br and 1 OH. So 3 rings, there are 6 Br and 3 oxygen. A total of 9 heteroatoms are there. So the value of X is 9. Coming back to, it says the compound P upon treatment with an excess of phenol. This was P. A parallel reaction is done. The compound P is subjected to excess of phenol. We know benzene diazonium chloride, excess of phenol under basic conditions. So benzene diazonium salts with activated rings, activated towards electrophilic aromatic substitution rings in basic medium, can undergo diazo coupling reactions, giving rise to diazo compounds which are good dyes, where the diazonium group is the electrophile, and this does electrophilic aromatic substitution on activated benzene rings like phenol, aniline, etc. Here we have taken excess phenol. So in all the three rings, diazonium group, diazo coupling can happen, and now you can write the product. The center benzene ring is here, and here you have a benzene ring whose diazonium group will couple with the phenol, giving an azo di group here. Diazo coupling reaction. Same thing happens at the third carbon, and you have N double bond N, and a coupling has occurred here at the para position. If para position is free, coupling will take place at para position of phenol due to steric reasons. And coming to fifth carbon again, you have benzene, and here you have N double bond N, and you put this OH group here. And this compound is called R. This compound is called S, This compound, the compound P on treatment with excess of phenol under basic conditions, give the product S. This is the product S, coupling reaction. And it says an important information again. The difference in molar mass between P and S is 172.5 gram per mole. So your P is this and S is this. So just analyze how much difference is there from this. From P, 3 chloride groups are gone. 3 chloride groups are gone, and instead of 3 phenolic groups have come. That's the only difference. So the difference in mass should be 3 times molar mass of C6H4OH group minus 3 times atomic mass of Cl. This should be the difference. This should be the difference. So when you do the molar mass of C6H4OH, it will come out to be 72 plus 5 plus 16, you get it as 93. 93 into 3, which comes out to be 279 minus 3 times atomic mass of chlorine, which comes out to be 3 into 35.5, which will come out to be 106.5. When you see the difference, it will come out to be 172.5 gram per mole. So you are perfectly correct what you have done is. So you have got your compound S, the final products S is this compound, and another final product R is this compound. R and S. Now in R, number of heteroatoms is X, which is 9. Coming to S, the total number of carbon atoms and heteroatoms present in one molecule of S is. So just count the total number of phenyl rings in this. A total number of 1, 2, 3, 4, 5, 6, 7 phenyl rings are there. Each phenyl ring has got 6 carbons in it. So you have 7 into 6 number of carbon atom, which comes out to be 42 carbon atoms plus number of heteroatom. Means you need not count hydrogens in this. So let us see the heteroatoms. Each ring, out of these 3 rings, each ring has got 2 nitrogen and 1 oxygen in it, meaning 3 heteroatoms. Like that, there are 3 rings. So 3 into 3, 9 heteroatoms are there, coming out to be a total of 51. Total of all carbon atoms plus heteroatoms comes out to be 51. So your Y is 51. So you have got x as 9 and y as 51. The question is, what is the value of x plus y? X plus y is 9 plus 51, 60 is the answer. So a question from nitrogen containing compounds. The very first concept is reduction of nitrobenzene to aniline with tin in HCl. It can also be carried out with iron in HCl also is normally done. So here the reagent is tin in HCl followed by diazotization reaction which is done with NaNO2 in HCl under ice cold condition. Aniline undergoes diazotization. All the aniline groups will get converted into diazonium chloride, followed by treatment with water at room temperature. So we know diazonium salts with water, especially benzene diazonium chloride with water at room temperature undergoes nucleophilic substitution reaction where all the diazonium groups will be substituted by first by water followed by deprotonation and you will get an OH group there and Q is this. Parallelly, P is treated with phenol in basic medium. The reaction is coupling reaction where diazonium group acts as the electrophile which does electrophilic aromatic substitution on an activated benzene ring like phenol, aniline, etc. Here we have taken excess of phenol in basic medium so that all the N2Cl position coupling takes place and you get diazo dies there. Now, as per the difference in molar mass, we have calculated, it comes out to be correct. Number of heteroatoms in Q, number of heteroatoms in R is X is 9 and number of heteroatoms plus carbon atoms in S is 51. Total X plus Y is 60. Thank you children. Thank you.